So far in this Kafka series, we built producers, consumers, understood partitions, rebalancing, offset management, and so on. But in real production systems, nobody writes custom producers to read from MySQL, and nobody writes custom consumers to push data into Elasticsearch. Instead, we use something called Kafka Connect, a scalable, fault-tolerant data integration framework built on Kafka. In this video, we will not only understand Kafka Connect deeply, we will also build and run a complete working project. We will see the CDC, change data capture, in action, which is being used in most of the distributed systems. So without wasting time, let's get started. So what is Kafka Connect? Kafka Connect is a framework that moves large amount of data between Kafka system and the external system. Now external systems, for example, MySQL, PostgreSQL, MongoDB, Elasticsearch, S3, file system, and so on. Right? So if you see, this could be our external systems, and if you see, the Kafka Connect sits between external system and the Kafka cluster. So Kafka Connect is not a producer, not a consumer, not a stream processing, but it is a data integration framework, right? So its job is to just move the data from external system to Kafka and also from Kafka to external system. Now let me erase this. Now the next question is why it exists. If Kafka already has producers and consumers, why do we need Kafka Connect? Now let's take a use case that you have a MySQL database and you have to read from this MySQL database and push this data into the Kafka. Now without Kafka Connect, what would you do? You have to write the producer application which would continuously read the data from the database and feed it into the Kafka system. Now if you see, this producer has to do a lot of other work as well. So first thing, it has to continuously poll the database. The next thing is it has to handle retries, because if the database is down for some amount of time, it has to handle that. It has to manage offset, that is what is the last record which this producer application has published to the Kafka. It has to handle scaling, it has to handle fault tolerance, it has to handle schema changes. So if you see, there are a lot of other things which this producer application has to do, and this is the kind of very basic requirement, right? You just need to feed the data from MySQL into the Kafka. Whatever data is coming to the database, just feed it into the Kafka system. Now you are not the only one who has this kind of requirement, because there might be many teams, many companies who had similar kind of requirement. So everyone in the world would be ending up writing the same integration logic again and again. So that's a duplication of effort. So Kafka Connect solves this problem. What it provides is, it provides standardized data integration, right? So if you see, it sits between Kafka cluster and the external system, right? So it provides the standard integration framework, right? So what it does is, it provides the connectors. So there are different type of connectors which I will be talking about in coming time. So if you see, Kafka Connect gives you a framework, standard connectors, pluggable architecture to move data from external systems to Kafka and also from Kafka to external systems. Now, what other problems Kafka Connect solves? So if you see, without Kafka Connect, you have to handle the scalability. Producer application which is continuously reading the database, and it is a single instance. What if database has 1 million rows? Your traffic increases. Now this producer has to manage partitions, parallel workers, and lot of other stuff. So Kafka Connect solves all of this using tasks, distributed workers, automatic rebalancing, which I'll be talking in some time. Now without Kafka Connect, there is one more big problem, right? The big problem is the fault tolerance, right? So let's imagine if your custom producer crashes, how it would fetch the data, how it would maintain, where was the last row read, did we lose data, did we duplicate data? So you have to manage offset storage. So this producer has to manage offset storage. It has to handle the recovery logic. It has to manage retry handling. But Kafka Connect already does all this via some of the internal topics. So what Kafka Connect does is it creates some of the internal topics inside the Kafka cluster where it would store the offsets and also the status of the job so that the distributed coordination can be done easily. And also Kafka Connect provides already so many connectors available. So for MySQL, it provides one connector. So for PostgreSQL, MongoDB, Elasticsearch, S3, JDBC, Redis, Cassandra, so it has lot of connectors available. So instead of building integration yourself, so what you can do is you can use battle tested connectors which has already been tested at lot of data. So Kafka is a central event streaming system. Kafka Connect is the standardized bridge between Kafka and the external systems. So it ensures loose coupling, standard data ingestion, and reliable data pipelines. So Kafka Connect exists so that engineers don't have to reinvent data integration every time they connect Kafka to the another external system. Now let's discuss the Kafka Connect architecture in detail. So as we discussed, Kafka Connect is a distributed, fault-tolerant data integration framework built on top of Kafka. So Kafka Connect architecture has 5 main layers. So first one is external systems. So if you see these are the external systems. The second thing is connectors through which these external systems are connected to the Kafka Connect cluster. So these are connected via the connector. Let me write here. So first point is external systems. The second point is the connectors. The third point is connector has to do some kind of job. So for example, reading from the MySQL database or reading from NoSQL, MongoDB, reading from Redis or reading from file system or reading from S3. So this is a kind of task. So third layer is the task. Tasks are created by the connector, and then there is a workers who basically runs the task. So if you see, the Kafka Connect cluster has workers who would run the task. And then the fifth thing is, very important thing is, the Kafka Connect cluster creates some internal topics in the Kafka cluster for coordination of workers to know the status of the connectors, whether the connector is running or not, or what is the last offset it has read. All those things it manages via the internal topics. Now let's go layer by layer. So external systems, basically these are the databases, for example MySQL, Postgres. Then it has search engines like Elasticsearch. It could be your data lake, for example S3. It could be NoSQL, for example MongoDB. It could be Redis. It could be Cassandra. So external system is kind of standardized systems which are already available and also being used in distributed systems, right? So Kafka Connect acts as a bridge between these external systems and your Kafka cluster. Now the second point is the connectors. Connector is a high level job definition. Now there are two types of connectors. So first thing is source connector. So what is a source connector? So whenever you want to read from the external system and write to the Kafka. So for example, you have the MySQL database and you want to read from MySQL database and you want to feed the data into the Kafka. Now for this kind of use case, you would use the source connector. And if you have a use case, for example, you want to read from Kafka and you want to feed the data into Elasticsearch, S3 or any other database, for example MySQL, PostgreSQL, right? So for this use case, you would use sync connector. Connector does not move data directly, so it creates task, as I earlier mentioned. Now let me erase each and everything so that I can explain more better. Now this is a very kind of high level layer by layer thing which I have already explained, but let me go deep into all of these layers. Now let's discuss about the connector a bit more. Now what is a connector? A connector is not something magical built-in component available already in the Kafka Connect cluster. No. It is simply a Java plugin, a jar file, right? So connector is nothing but a Java jar file. So what would happen is when you spin up this Kafka Connect cluster, right? So you would include in the class path all those jars. I would explain better in sometime soon when I will demonstrate the real working example. So the connector I explained is a Java jar file. Now the connector could be many connectors. So for example, for MySQL, there could be a different connector. For PostgreSQL, there could be a different connector, right? And similarly for S3, there could be a different connector. So there are a lot of connectors available, right? So what would you do is whenever you spin up this Kafka Connect cluster, you basically mention the path where all your connectors are available. So for example, you mention the path. Now in this, there's a path called plugin.path. So this path specifies where your all connectors are available, right? So connector is nothing but your jar file. So let's say you have the plugin path as user, share, Java, let's say the libs. So your all connectors should be available in this path. Now, when you spin up this Kafka Connect cluster, you need to specify which connector you want to use because you have a lot of connectors available, right? But you need to specify which connector you want to use. So you specify in the connector configuration, right? So you would specify something like that. You need to specify the class because every connector is a jar file. So you need to specify the class file name, right? So for example, connector.class, and you need to specify, for example, if I am using the JDBC source connector, so you need to mention that class file name, and it should be with the fully qualified name with the package. So for example, io.debezium.something something, right? So it has to be fully qualified name. So package name and then the class name. So you have to specify which connector you want to use. So this connector, so let's say this is the connector which I specified that I want to use this connector. So there are standard APIs which are provided by the Kafka Connect. So for example, for any connector to be acting as a source connector, so it has to extend or implement few of the methods as usual. To create a source connector, so this class, if it is a source connector, it has to extend this source connector class and it has to implement few of the methods, right? And similar for sync connector. Every connector has to implement the Kafka Connect APIs. It has to extend source connector or sync connector. And then this class has to create a task as well. And tasks are something which would be executed by the workers. Let me erase all this. So in simple terms, connector is a jar file, right? Is a Java class basically which you specify in the configuration. It is packaged as a jar and it is loaded by the worker. Now, as I mentioned, where do these jar files live? So that is a kind of plugin path, right? So I'll explain better when I demonstrate this Kafka Connect. Now you have connectors, that is jar files. Now you need to give some configuration to a connector, right? So for example, this is the connector, right? So you are in your use case, let's say the database is there and you are using the JDBC source database connector, which would continuously reads the data from this database and feed into the Kafka system. Now this connector has to provide some configuration. The configuration could be which topic, right? To which Kafka topic it would feed the data. So from which database table it would read the data, right? And how many tasks it wants. And connector has to specify at least one task, right? And if you need more parallelism, you can define more than one task. So for example, if you specify the task as 3, that means for a particular connector, you would have 3 parallel tasks. It is similar to you have 3 partitions. Then these tasks are being executed by the workers. What are workers? The workers are nothing but they are the actual JVM processes which are running inside the Kafka Connect. And to this worker process, we provide all the path. For example, in the class path, we provide the jars directory so that it loads all the connectors available. And then at runtime, we can configure which connector we want to use. So workers are responsible for running connectors and tasks. Now, when we talk about workers, there are two modes of running the worker. One is the standalone mode and the other is the distributed mode. Let me erase all this. Now, standalone mode means you are running a single process. That means single worker JVM process, right? So in this case, you don't have any fault tolerance, right? No fault tolerance is there, because if this worker is crashed, that means you can't do anything, right? So it is good for development and testing, and it also stores the configuration locally. So in that case, it does not create the internal topics. Now, why it doesn't create the internal topics? Because it already knows that only single JVM worker process would run. So why it needs to manage all those information into the Kafka cluster, right? So it is being used internally just for development, right? So that is the reason no internal topics have been created. Now in distributed mode, you have multiple workers. You have fault tolerance. Because you have multiple workers, you automatically have the fault tolerance. It automatically does the rebalances as in when any worker goes down. In distributed mode, you also have REST APIs to configure connectors. So for example, you have lot of connectors available, but if you want to change the configuration or if you want to add the connector at runtime, you have a provision. You have REST APIs, because in production, you don't restart each and every time, right? So there is a REST service which you can use to configure connectors. So it is a production ready kind of setup. In today's demo, we will also use the distributed mode. Now, when I say Kafka Connect cluster, so in this case, do we provide any cluster ID, or how this cluster gets set up, right? So that is a very important question to understand, right? So what happens is you have the workers. So as I mentioned, worker is a JVM process. And if this JVM process is using the same group ID, let's say the connect cluster is the group ID, and same internal topics, same Kafka cluster, that is bootstrap server, same internal topics. So it automatically forms a Kafka Connect cluster, right? We don't need to provide any cluster ID or we need to set up a different cluster altogether. No, we just need to instantiate or spin up these workers on multiple machines. Let me erase all this. Now let's discuss the most important layer, that is internal topics. So in distributed mode, Kafka Connect uses Kafka itself for coordination. So it creates three internal topics. So first one is connect configs. Let me write here instead of there. So it creates topic connect configs. So what it does is it stores all the connector configurations, and whenever you spin up any worker, right? So you spin up JVM process. So it's a JVM process, right? So you spin up Kafka Connect worker. What it does is it first of all sees this topic and it gets all the connector configurations, right? So this ensures centralized config storage, no local dependency. Now the second topic it creates is connect offsets. So it stores source connector offsets, and it is used only and only by the source connector. Sync connector never uses this connect offsets topic. So what it stores is, it stores, for example, last row read from MySQL or last file position read. So basically this ensures no data loss and also recovery after the crash. That is why this topic is being used. Now the third topic which is being used is the connect status. It stores the status of the connector, that is the status of the task. So for example, if the task is running, failed, paused, what is the current status of the task? So it stores all that information. So each and every Kafka connector is kind of publishing the heartbeat to this topic every interval. So for example, the JDBC source connector is continuously publishing the heartbeat. We can configure that heartbeat periodic interval, right? So it kind of does the heartbeat pinging and also pinging that whether the connector is in running state, failed state, or the past state. So this enables monitoring, rebalancing, health tracking, right? With this topic only, the worker would come to know whether the rebalance needs to be required or not, right? So if the worker is not able to ping the heartbeat in, let's say, 1 minute, so the other worker would know that the respective worker is not available, and it would trigger the rebalance. So this topic is kind of very important topic to have the fault tolerance and to have the system continuously running smoothly. Now let's see the complete flow end to end, how the things are happening and how the communication is being happening throughout the flow. So what happens is, as and when workers start, so it has to connect with the Kafka cluster, right? So it has to provide some kind of group ID and also has to provide the bootstrap server. So it's a kind of simple process, the JVM process, right? And simple, you can imagine like consumer, right? So for consumer, right, and there could be multiple consumer, 1 2 3 4, right? If the consumer, every consumer has the same group ID, right, and it has to connect to a topic, right, to which topic it would be connecting. So the topic, it is trying to connect with all the three topics, right? So 1 2 3, the connect config, as I mentioned, right, the connect status and the connect offsets. So these are the three topics, and every topic has single partition, right? So what would happen? So one of this consumer would be acting as a leader, right? So similar to this, if you have multiple workers, worker 1, worker 2, worker 3, right? So what would be happening is Kafka would be electing one of the worker as a leader. Now this leader would be assigning the task. Now this is a kind of what would be happening in this connect connector class implementation. What would be happening is, then as I mentioned, right, on partitioning callback or on partitioning assignment, right, and there they have written a logic, they are assigning the task, right? So assignment is stored in Kafka, right? So as I mentioned, the connect config, right, so it stores all this configuration, what are the tasks has been assigned, right? So this leader would assign the task to the worker and would also store into this Kafka, right? Now the workers would be executing the task. Now worker would be picking up the task, what connector is executing which task, that would be read from this topic, the connect config topic. So if you see, workers are not communicating among themselves, right? So there is no direct communication between workers. They coordinate through Kafka. Kafka acts as a config store, Kafka acts as an offset store, leader election system, task assignment coordinator, everything. So that's a brilliant distributed design, right? Because they are not handling each and everything on their own. They have just offloaded all things to the Kafka. That's how the complete flow is working. Now let's see how rebalancing happens in the workers in Kafka Connect cluster. Now let's discuss that part. So first of all, please watch the partition rebalancing video I made on my YouTube channel. I will mention in the description, and also you can see the iCard top being shown over there, because that is a prerequisite video for this kind of understanding, right? Now rebalancing happens when worker join, worker leaves, or connector configuration changes. So for example, in this use case, we have 4 workers, worker 1, worker 2, worker 3, and worker 4. These are the 4 workers we have, and we have 3 connectors. Let's say one connector is reading from JDBC and feeding to the Kafka system. The another connector is reading from Kafka and feeding to the MongoDB, and also the third connector is feeding from Kafka and feeding into the Redis. Let's say these are the 3 connectors we have. Now as I mentioned, connectors can mention the task, how many tasks it needs to have more parallelism, right? So in this case, for example, connector 1 task have been assigned to worker 1, worker 2, and worker 4. And similar to this, the connector 2 tasks are being assigned to worker 1, 3, and 4. And similarly, connector 3 tasks are being assigned to worker 1, 2, and 3, right? So this is the kind of configuration we have. Now suddenly what happens is, if worker 4 crash, right? Now Kafka would trigger rebalance, okay? But how it would trigger rebalance? So it would trigger rebalance via the Kafka Connect topic, via the connect status topic. This worker has not published the heartbeat in periodic interval. So all the workers would know that something is messy, right? Some of the worker is down because this worker's status is quite old, is not updated. So what would happen is the rebalancing would be happening. Then what has happened is connector 1 task has been moved to worker 3 and connector 2 task has been moved to worker 2, right? So that's how this rebalancing has happened. Now you would say, okay, the rebalancing has happened, now the data would be lost. I would say no, because the offsets were already stored in the connect offsets topic, right, as I mentioned earlier. So no data loss. On rebalancing, what would happen is every worker would again fetching the data from the connect offsets topic, and it would fetch the last row what it has already fed, and it would start resuming from the next row, right? So that's how it would work. Now let's again see the complete flow. Very first step, the workers would be reading configuration from the connector config topic, as I mentioned, right? This is the very first step, right? So they would be reading from the topic connect configs. Then the workers would be instantiating connectors. The connector would be creating tasks based on the configurations, whatever we have already stored or mentioned. Then the fourth step is task poll the external system. So this is the main job unit who would be doing the actual work, and then task would be kind of converting the data using converters. Then it would be writing the data to a Kafka topic, and then once it has been written to a Kafka topic, what it would do is it would store the offset in connect offsets. This is the complete flow for the source connector. And for sync connector, it's very simple. For sync connector, task would be consuming data from Kafka topic, converts the message and writes to the external system. It's quite simple. Now let's move to the demonstration part. So what we would be having is, we would be having two services, the order service and the analytics service, right? So you can imagine the order service is continuously inserting the orders into this database. For simplicity, let's say this database is the Postgres database, right? And we have used the Kafka Connect cluster here, which would continuously stream the data from Postgres to the external systems. Now when I say external systems, external system, when I say, it could be the other database like the analytics database, which is being used by the analytics service, and also it might insert the data into the S3. This also being used by the analytics service, right? When you would be reading the data from the Postgres and feeding to the to external system, right? So at this point you would be using the source connector. When you want the data to be read from the Kafka, right, from the Kafka to the external system, you would be kind of using the sync connector. And what we would be doing is, we would be inserting the data via the REST APIs, creating some orders into this database, and then this Kafka Connect would be publishing this data to the Kafka, right? So for example, this here, the source connector would be having the configuration like the database, the topic name, for example this topic name, which topic it is, let's say the orders is the topic, right? And to this topic the data would be continuously published, right? And the sync connector would be continuously reading the data from our orders topic and would be kind of inserting the data into the external system, right? So sync connector would be reading this topic called orders topic, where the source connector is kind of publishing the data, and the sync connector would be using this topic and inserting the data into two of the external system. So for example, this database and also to S3. And we have the analytics service, which would use this S3 and also the analytics database. So we would be demonstrating this kind of setup. Now let's move to the IntelliJ and see the code. So this is the IntelliJ project which I have prepared, right? So as we discussed, so there are two services, the order service and the analytics service, right? So as I mentioned, the order service would be persisting the data into the database, right? So if you recall, the order service would be persisting the data into the Postgres database via REST APIs. So it is a kind of Spring Boot application, right? So we have the web module, web package where the order controller has been exposed, right? So don't worry about each and everything. I will be explaining each and every stuff. So it's a normal simple CRUD application, right? So the order controller is there, right? The API orders, and I have not created this service layer because our job is to do the POC for the Kafka Connect, right? So our job is not to write each and every layer very confined and very fine-grained way, right? So that's the reason I just directly injected the order repository here, right? So this is the API, the orders, API orders, and with the post mapping, it would be creating the order in the pending state, right? And for getting the order with respect to any specific ID, so you have this API, and then if you want to get all the orders, so this is this API, you can just call this list orders method. And if you want to know the status of any order, so for that there is this API. So all these APIs are there, right? So it's a very simple CRUD application, right? So if you see the repository, the order repository is nothing. It is just that we are just calling directly this save method from the controller layer itself, right? So it is kind of doing nothing, just persisting into the database. It is not publishing onto the Kafka. No, it is just persisting into the database, and our source connector would be kind of polling the database and would be publishing the records onto the Kafka cluster. So that's how it would be. We are running this on port 8080, right? And we are using the Spring Boot with the Hibernate. And similar to order service, we have the analytics service, and the analytics service is also a kind of the Spring Boot application, right? So if you see the POM, the Spring Boot starter parent, and there is nothing, just the normal dependencies, which are kind of very 2 to 3 dependencies, not more than that, right? So the Postgres for connecting to the database, and then the min IO is something which I am using for local demonstration instead of using the S3. Min IO is kind of S3 compatible object storage library which we can use. So even if you have to use S3, you can use the min IO library to directly access the S3 buckets. So kind of that, right? Now if you see the analytics controller, right? So analytics controller is doing nothing. It is just having order repository, right? Orders event repository and the S3 analytics service, as we mentioned, right? So the analytics service would be kind of accessing this external systems, the database and the S3, and who would be publishing or who would be feeding the data into this database and the S3, that is the sync connector, right? So if you see, there is no sync configuration here, right? So because that is being managed by the Kafka Connect. So if you see, there are just few endpoints just from orders from DB, right? It is just doing nothing, just fetching the data from the database. And similarly, for accessing the S3, we are just having the S3 analytics service, right? So if you see over here we need to pass, because I would be using the min IO compatible on my local machine. So for that, I don't need any S3 AWS key or anything like that. I am installing the object storage on my local machine as a Docker container, which I would be explaining in some time soon. And this is the kind of API, the client, and we can get the list of buckets, what all buckets we have, and if we want to traverse or want to see what kind of object content is in that file, we can see that, right? And these are the very normal APIs. if you see the analytics controller, it is doing nothing, just returning the object keys and also returning the object summary, all the how many orders are there, how many files are there. We have gone through the order service, we have gone through the analytics service. Right now the thing is, where is the Kafka Connect? As I mentioned, how we were installing the Kafka cluster, by the way, if you have followed my all the videos, for Kafka cluster installation we are using Docker container, right? So similar kind of thing we are using for Kafka Connect cluster as well. So this is the kind of Docker compose file, right? And this is the Kafka cluster, right? So if you see here, the same version I'm using, right? So but here I have given some host name and container name as the Kafka, and these are the ports I have exposed. So if you have followed my cluster communication in the Kafka episode 13, right, so there I have explained each and everything, the listeners, plain text, controller, and the external, right? So I have explained each and everything in very detailed way. So 9092 is something for external communication and 29092 is for internal inter-broker communication, and the control plane communication is happening via the 9093, right? So I have just exposed all these ports over here, right? But the advertised listeners are something which has to be used or which can be used by the outside world or also by the inter-broker which are there in the Kafka cluster. So everything I have explained there, the quorum voters. So here what we are doing is we are just installing the single broker. So the quorum voters, that's why we have specified that the node ID at the rate the localhost and the 9093, right? So we have explained each and everything. The node ID we are providing as 1. The kind of auto create topics, we are just passing this as true, and the log directory I have passed this as, this is the directory where the Kafka would be storing the logs. So this is the kind of Kafka cluster which we are already familiar with, right, and already explained in my earlier Kafka videos, right? Now the thing is, we need the orders DB, right, because order service would be persisting into the orders database, right? So for that, what I have done is I have created the orders DB also as one of the service, and what image I am using is the Postgres, because what I explained, I would be using the Postgres database, right? So that is why I have used the Postgres, and the host name I'm giving the orders DB, the containers name I'm giving the order DB, and the port on which the order service would be connecting to this database, that would be the 5432, and this would be the user, the order user, and the password is the order password, right? So and the DB name is the orders, as I mentioned, right? So the Kafka Connect source connector has to somehow stream all the database changes, whatever has been happening onto this database, right? So it is not something it is trying to get or firing the select query, select star from T orders, right? It's not like that. The database changes, whatever has been happening or operating onto the database, those are happening via the wall file. So write ahead log file. So everything is stored in that write ahead log file with the log sequence number. Postgres provides the functionality where we can replicate all the logs, whatever we are having onto the wall, to the end systems, right? So that is what it is also doing, right? So that is the reason why I'm doing here as well, right? The Postgres, so what it would be doing is we need to enable the wall level, that we need to enable the logical replication, right? And how many slots we want to open for replication is the 4, and the wall senders is also 4. So this is a kind of basic configuration which we have to do to enable the replication. So if you are worried about this, I have published a detailed video on how OpenAI has scaled Postgres for 800 million users. I will mention that video also in the description. You can have a look at that. This is the kind of health check which we have. The Postgres already provides the PG is ready utility, right? And it checks the health check whether the Postgres is available or not every 5 seconds, and the number of retries it can do is 5. So this is a kind of basic database we have used for the Docker image, right? Now the other database what we need is the analytics database, right? So it is more or less the same. So we are using the Postgres database, and the host name and the container name we are passing the analytics database. So inside the container it would be running in the 5432 port, but since I am running this also on my local machine and I want my service to access or externally, so that is the reason I am exposing different port onto my host. So the port which I am exposing it 5433, and the database user is the analytics user, and the database password is the analytics password, and the database which we would be using is the analytics. Here, since there is no streaming required over here, that is the reason we have not mentioned any command, right? So in what manner we want to run the Postgres, right? So we never mentioned that. So what we did is we just mentioned that okay, here is the directory where all the data would be stored. So we have scripts for different database. So for example, for order database I have the ordersdb.sql. what it does is it has some DDL statements which would create the database table if they does not exist, right? So creating the index onto the some of the columns, right? So the orders table have been created over here, and now as I mentioned, the replication which we need to specify, right? So we need to enable the replication, right? So that also I have mentioned over here, right? So if you see the replication user for Debezium, so we are creating the user Debezium with replication. This user is eligible to stream the vol file logs into the application, right? So that specifies this thing, and the password is also Debezium, and it has given all the access to all the tables. So kind of that. Now if you see the analytics database, so it doesn't have anything. It is just creating the orders events table if it does not exist, and some of the indexes. That's it. These are the basic SQL queries which we have used in our Docker file, right, which we would be using as and when these containers are coming up. Now let's see the other part. First of all, let's see the order service, right? So what we are doing is the order service, we are using the order service also we are running in a Docker container, right? So as I mentioned, the port is 8080, and if you see the database it is using is the ordersdb, right? So the database source user name, password we have already seen upwards when we were accessing the database, right? So if you see the order user and the order password, right? So the same we are using over here as well. Now let's see the analytics service. So it also have nothing. It just depends on the analytics database. The condition is the service healthy, right? And then the Kafka Connect and the min.io, which we would be seeing in some time, right? And the port which I have exposed is 8081, right? And the analytics service would be connecting to the analytics database which we have seen earlier as well, right? And also because this analytics service is not accessing only this database, but it is also accessing the S3. For S3, what I have done is I have just mentioned the min.io endpoint. So this is the kind of S3 which I have been installed as a Docker image in my local machine. So this is quite compatible with the S3 as well, right? So the min.io access key, the min.io secret key. So this is the kind of username password I will show you in some time, and this is the min.io bucket, right? This is the bucket, similar bucket which we will be creating in the S3. Now let's see the Kafka Connect. Now, as I mentioned, the Kafka Connect is nothing. It is just a Java JVM process, right? The worker would be spinning up, and it would be spinning up as a JVM process, right? So what it does is, so Kafka Connect depends on the Kafka orders database, analytics database, and the min.io, right? So these are the things which it depends on. And as I mentioned, it exposes the REST API in distributed mode where we can configure the connectors at runtime. And as I mentioned, the Kafka Connect worker has to pass the group ID, right? And also has to pass the Bootstrap server, right? So if you see the group ID which we are using here is the Connect cluster, I already mentioned, right? And the Bootstrap server which we are using is the interbroker communication, the Kafka 29092, which we have seen upwards, right? And the advertised hostname which we would be using for external applications for connecting to this Kafka Connect, we would be using this hostname. As I mentioned, there are 3 internal topics which Kafka Connect would be creating, right? So first one was the connect config, the next one is the connect offsets, and the connect status. As I mentioned, in the complete flow, what would be happening, right? Connector would be kind of reading the data, and then it would be kind of converting the data into a particular format, and then it would be publishing to a Kafka topic, right? We discussed this. So that is where the converters are coming, the converter, key converter, value converter, right? And this is something you don't need to worry about this. So schemas enable. So if you want your data contract has to be validated, so that's where you use the schemas enable. As and when the worker spins up, it has to know what all connectors are available, right? So there is a plugin path directory which I mentioned, right? So in this directory we can mention or we can place all the connectors, the jar files, right? So we can place all the required jar files whichever we want to use, either in this directory or in this directory, right? So we can place in that, and what would be happening, as and when this connector or worker process would be coming up, it would be loading all the connectors available to them. At runtime, we can decide whether we want to configure or whether we want to switch on any of the connector or not. So if you see the CMD, it's a kind of the REST API, it's doing nothing. It is just checking whether the response is 200 okay or not. That is it, right? So because in distributed mode, it opens up the REST API as well. It provides the REST API. Now let's see the min.io. So if you see, I'm using the min.io image, and the port is 9000 and 9001. We can access the min.io using 2 ways, either via the web or via the console. If we want to access via the web, we can access at this, like localhost @9000, but if we want to run via the console, we can run at 9001. Now the min.io initialization, right? So this container is just for initializing the min.io, so creating the prerequisites, but this container would be just doing its job and it would be exited, right, immediately. So what it would be doing is it would be kind of creating the bucket with the orders events name, right? So if you see the min.io, this is the make bucket, right? Make bucket in this with this name, the orders events. Let's see, the other part is the connector initialization, right? As I mentioned, in distributed mode we have the REST APIs available, right? And we can specify what all connectors we want to run. The connectors are available to the worker, all the connectors are available, right? But we can mention what all connectors we want to run. So this is just for simplicity I have done, so that I don't need to do it manually. So that is the reason I have done this way. So what it would be doing is it would be kind of running this script on startup, right? So if you see the entry point, it is kind of running this script. So I would be coming onto this file in soon, but first of all, let's see how we are placing the jar files into this directory. So into this directory we need to place the jar files, connectors, right? So how we can do that? Now for that, what I am doing here is, so if you see, there's a Kafka Connect folder. If you see the pom.xml, I'm using 2 jars, right? So Kafka Connect S3 and the Kafka Connect JDBC. If you see the Docker file, how I would be doing is, I have the pom.xml. In this pom.xml, what I would be doing is I would be having the jar files, right? So when I would be creating the Docker file. So in this what I am doing is I'm just kind of copying this pom.xml to my image, right? And in this what I will be doing is I am using the install apt-get install maven, right? And with this, when I install this, I get all the dependencies available. So it would be available in the temp connectors. If you see the Debezium, I'm getting directly, but if you see the other thing, right, the Kafka Connect JDBC and the Kafka Connect S3, right, I'm copying this directly from temp connectors lib. So I have each and every dependency here, so I just need to copy into the specific folder, right? So I'm specifically copying the Kafka Connect JDBC to a different folder and then the S3 to a different folder, right? So I have both the jars, Kafka Connect JDBC S3 to the particular plugin path. If you see, this was the plugin path. Let me open the Docker Compose, right? Let me search this, right? So this was the plugin path, right? So in this path we need to place the connectors, that is the jar files. So that is the reason I'm copying in this directory. Now let's see how to configure the connectors. So for example, for Debezium orders source JSON, right? So if you see, this is the source connector configuration which I would be showing up right away, right? So it is a kind of connector must be having one name, that is the orders DB source, right? And it is kind of giving the connector class, right? What kind of class we are using to get the data, right? So it is a kind of Postgres connector. And what is the database host name? We have already seen the orders DB, the database user, Debezium, because for this user only we have enabled the replication, the database name, the database server name, right? And the tables include list. So here we can specify for what all tables we want to stream the data, right? And the slot name, it is kind of Debezium orders, right? Because we have mentioned the 4 replication slots can be created by this user. With this slot, this user continuously streaming the logs or the database changes into the Kafka, right? And this is the publication name, right? So if you see the orders DB SQL, right? So if you see, this is the kind of publication name, right? So replication basically in Postgres works via the publication and the subscription model, kind of the similar thing, right? The Postgres or the source database has to create the publication, and then whoever wants to get the data or stream the data, he has to basically use the same publication name with the replication to get the data. So that is the reason we are mentioning over here. And then we have discussed the key converters, value converters, the other stuff, right? So this is the kind of source configuration we have. And then we have the sync configuration. So if you see the sync configuration, similar kind of configuration we have, like the orders to analytics database. This is the kind of connector name, and the topic which we would be using is the order service public orders topic, right? So this is the same topic which we have used, where the source connector is kind of publishing the data, right? So this is what it is. And then the sync URL is kind of this analytics database and everything. So it is kind of inserting this data into this order events database table, and the field, whatever fields we want to whitelist, we can specify all those fields. So that is the kind of sync configuration. And now let's see the S3 sync configuration. It is more or less same. So it is also kind of what all orders we are persisting into the database, the same orders we are persisting into the S3 bucket, right? So it is a kind of same thing. From the topics, it would be using the S3 storage, and on which URL it would be storing this, the bucket name, right, the region, the topics directory, and the other stuff, right? So everything has been configured over here as well, right? So we have looked at the configuration, right? So or analytics service connectors and how this has been connected, the order service and the scripts. Now let's see the register connectors. orders.sh file. This is the missing part, right? So what we are doing here is, so as and when we are spinning up the Kafka Connect cluster, right? So what we would be doing, I am creating one container, right? Just for one time activity for registering the connectors. So as I mentioned, we have all the connectors available, but we need to register the connector, what all connectors we want to use, right? And because this is the kind of very first setup, right? So this is not mandatory. If you want, you can use or hit the REST APIs manually, but just for automation I have done this way, right? So you can have one container which would actually execute this script file, right? So if you go to this, it is kind of doing nothing. It is kind of basically passing this JSON, the connector configuration, which we have already seen, right? And hitting into this URL, right? So as I mentioned, there's a REST API, right? The Kafka Connect is being exposed at 8083. We are just sending the curl request with the configuration of the connectors, right? So configuration of the connectors and with this connectors endpoint. So this is the endpoint which has been exposed by the Kafka Connect, and we are just registering one by one each and every connector. So creating Debezium Postgres source connector, creating JDBC sync connector, creating sync S3 sync connector, and so on. So we are registering all the connectors, right? So now we have seen all the things. Now this is the readme.md file which I have created. So you can look at this readme.md file. Now let me bring up the cluster, right? So let me see the docker ps-a. There is nothing. What I'll do is docker compose up -d-build. So I will be just running this command, and let's see what happens is, so it is kind of doing all the build, creating all the containers, right? So just wait for a moment, it will just spin up the containers and everything. Now all the containers are up and running. So let me just show you the docker ps-a. So what we have the analytics service, we have the Kafka Connect, then we have the order service, then we have the min.io, then we have the Postgres orders database, then we have the Postgres analytics database, then we have the Kafka cluster, and then we have, this is the kind of initialization. We don't need that. This is the actual min.io, right? So we have each and everything, right? So what I'll do is I'll just open the, so what I will do is, let me open the readme.md file. So what I will be doing is I will be just looking at the connectors, what all connectors are there, right? So if you see, these are the three connectors: orders to S3 sync, orders database source, orders to analytics JDBC sync, right? So these connectors we have. Now if we want to get the configuration for any order, right, or any connector, so we can do this. Now if we enter this, if you see, the connector configuration is same, whatever we have passed, right? Let me open this. If you see, this was the configuration we have provided, right, through our JSON file. So if you see, this configuration is same, right? So the S3 region, the flush size, the task max, the topic is this one, right? So everything is same. So kind of, if you want to know the status, what is the status of this, so it would be retrieving via the connect status topic. So it would be kind of doing this way, right? So the status is running, and the task, how many tasks it has just one task, and with the ID as 0, right? So this is the kind of APIs we have for our Kafka Connect. Let me hit the orders service, or let me first go into one of the container, right? Docker ps-a docker exec-it. Let me go into the orders database first of all. So I am into the orders database container. So what I need to pass is tsql-u. Let me see the file orders database username password, right? So that was kind of this one. right? The host name is this, the order user is this. So what I will be doing is orders user, and then I would be doing the Postgres database is the orders. So what I will be doing is I will be doing select star from orders. I don't have anything. Now let's use the order service to publish the order, right? So for that there's an API which I have created, the localhost 8080 API orders and the customer ID. This is the kind of information which we can pass, right? And if we send it, it would create the order with the order ID 1 and the order number as this and the other details. Now let me do the select again. We are able to see the data, right? Now let me exit this and let me show you on to the Kafka topic, what all topic we have, right? And let me go inside the Kafka container, right? And now if you see opt Kafka bin, and this what I will do is I will first of all do the Kafka topics and do the bootstrap. So if you see, these are the topics. So this topics has been created automatically, and these are the internal topics which I have discussed. Right now let's see whether the data has been published here or not. So Kafka console consumer, and then again I just need to pass the bootstrap server, and then topic, the topic is this one, and let pass the from beginning, right? So if you see, this is the kind of payload, right? The payload was the ID1 with the other details, everything, right? So the order has been published successfully, right? Now let's go inside the analytics database, right? Let's go inside the analytics database and see whether the data is there or not, or let me hit the analytics endpoint as well. So if the data is there, that means the analytics service would give me the data. So let me hit this endpoint. Okay, this is post, we need to make it get. Okay, now if you see, the order is already there, the same order which we have mentioned, the order ID, order number. Let's validate this. The order number is this one, whichever has been published onto the Kafka topic. Let me search this into this, right? So this is the same order. Now let me show you the S3, how we can access the S3 as well, right? So let me go into the readme.md file. What I will do is I will just open this one, right? So this is the kind of Minio dashboard, right? So if we go there, now let me go inside this topic. So partition 0, and if you see, we do have just one record, right? Now let me publish one more record into the orders database, right? So let me just change the params, the body, right, to this one, sorry. So let me just insert one more record, let's say DEF, and the customer ID is, let's say, the 10. So I'll just publish this as well, and let's see. So this is the order ID which we got, right? And let me refresh this. So if you see, the second order we got. If you call the get API from this, right, and from the analytics service, you can have both the records available to you. So that's how we can use the Kafka Connect. I'll check in all this repository so that you can look at this, but I have tried my best to explain it as simple as possible. So that's all I had planned for today. I hope you like the video. If you do, please do like, subscribe, and share the channel with your teammates and other friends. It really helps the channel. So thanks for watching. See you in the next video. Thanks.